We have roughly 10 minutes time for questions, and there is the first question by Brian in the chat. Brian, you want to ask your question?
Hi, Steve. Thanks for the talk. Very informative for me, at least. So I had a question about the array descriptors. Are they mandatory only for assumed shaped arrays, or are there cases when you would use them with arrays or array, dummy arguments that have fully specified shapes?
All right, well, if there's Fortran experts on this, they might get me on this, but I'm pretty sure that you don't know who you're calling all the time. And so when you don't know who you're calling, then you just would not pass a descriptor, you would just pass the array, because then it would treat with the F77 semantics. But if you're calling something with an interface, then you would know from the interface whether you needed to pass the descriptor or not, and most of the time you would. In fact, most routines would expect a descriptor because they don't really know all the people that are calling them, if that makes sense.
I see. So okay, this is probably a more general language question, but kind of off topic. So what is how do you determine from the interface whether a descriptor is expected or not?
I don't know.
Okay, well, I'll go back to the textbook. Thank you very much, Steve.
Yeah, maybe somebody else from the team can.
Yeah, two people just unmuted that want to answer that one.
Yeah.
I'll let the other one.
Rich.
Okay. You require an explicit interface if you're going to pass an array by descriptor. So that means both the caller and the callee know that they need to either generate or expect a descriptor. And it's for use whenever the dummy argument has the pointer attribute or is assumed shape, that sort of thing. There's a whole list of things in the standard or in any good textbook that would itemize what those things are. There's 5 or 6 of them.
Great, thank you.
Thanks, Rich.
Your affine example in your lowering. You had the Fur MLIR dialect, right? And then you lowered that to the affine dialect. Did I understand that correctly?
Yes, that's correct.
Is that, like, do we know that a Fur do loop can always be lowered to an affine do loop, or is there analysis required to do that lowering?
There was analysis required to do that to make sure that all the loads and stores inside of the loop conform to the requirements of the affine dialect.
I see. Okay. Yeah, that makes sense. I was just curious.
Yeah, and it's fairly new. I don't know if it's possible, if we find some problems or some reasons that we couldn't, if we could rewrite the Fur to be acceptable for the affine dialect. I don't know, hoist things out, recast things.
Yeah, there's a lot of things you can do to make something, affine is the wrong word, but acceptable to what the affine dialect actually wants as input, which is kind of representable in a polyhedral model. So, and a lot of things you might want to look at. Do we have more questions?
This Kelvin. Hi.
Yes, we can hear you. Go for it.
But is there any optimization in the Fur kind of level? Like, for example, if I have an array A equal to array B, do we do any kind of replace it by a mem set or that, also some mem copy, that kind of thing?
There, in the Fur level, there's no particular optimizations that are being done at this time. Yeah.
Okay.
Maybe the high-level question that is always asked. The example you've showed was obviously like slide code with the trivial 2 loops. You want to remove the temporary. That looked an awful lot like the example we've seen in the IBM talk that Whitney showed, where you had 2 loops, you wanted to fuse them, remove the temporary. So how would you describe why the Fur affine dialect MLIR route is superior to the LLVM-IR route to do that?
Well, I don't know. This is really our first experiment with the MLIR route. So I don't really have a good way to compare the two yet. I would say that the representation of addresses in MLIR seems to be at a higher level and more in tune with what Fortran has. So it's possible, maybe to do the same things that you can do in LLVM-IR, but without having to reconstruct the data structures by representing things at a high level, keeping them as loops, keeping them as boxed addresses and boxed descriptors. We can simplify the analysis. And if there's information lost in successive optimizations to prevent things from being recovered at the LLVM level, then maybe there would be some more optimizations there. But it's just, we're so early in the game with MLIR and that I really can't say that there's a difference. Although when we first saw LLVM-IR, we did think that, well, we should go this route because it can't hurt because we'll lower to LLVM anyway, and we'll be able to do progressive lowering. And if the payoff is good, then of course we'll be right there. And a lot of what happens in AI languages, where there's very many vector times matrix, matrix convolutions, are very similar to the HPC codes that we see. So if there's a lot of optimization that happens, optimizer work that happens in MLIR will pay off greatly for Fortran programmers. And that same focus might not happen in LLVM-IR because there's not that intense focus on AI model optimization in LLVM-IR as there is in MLIR or other higher level representations that I know of.
No, makes sense. Makes sense. I think, Brian, you want to add something?
Not really, no.
Oh,
I think Steve already answered my question. Thank you.
Okay, because I thought you unmuted. Okay, then the last question. You said the address calculations or the address representation is higher level. I get that with the boxes, but did I misunderstand that there was some address calculation in the examples that flattened the address?
Yeah, it seems to be that the representation stays at a pretty high level, and then there's the coordinate, or I forget what it's called in MLIR operation that goes and flattens it again. The
Okay.
apply.
How is that different
Turns it
from
into an
the?
index.
How is that different from the get element pointer that flattens things? I'm not an MLIR expert, so this is like a genuine question.
Yeah, I'm not an MLIR expert either. If Eric was on the line, he could help me out there, or somebody from the MLIR team.
It's fine. Maybe someone wants to speak up. Otherwise, it's fine. We can figure it out later.
Yeah, this is the work of, we have an intern this summer, and this is his work. And he was not able to present this morning.
That's unfortunate.
It is. Oh, it was unfortunate for us that we have an intern who could do this. It's awesome.
Oh, no, the presentation part, not the first part, obviously.
Yeah, I understand.
Okay, I think we had a couple of good questions. Thank you very much for giving the talk, and instead, such that we can see all the stuff that the intern did, and thank the intern for the interesting work.